Hello, everyone. My name is Rob De La Espriella, CEO of DLE Technical Services, and I'd like to welcome you to our webinar on why organizations are choking on the fishbone. And we're happy to see a lot of you here from as far away as Qatar. We have the UK represented, also Canada, and of course, the majority of you are from the United States. So it's nice to have a great turnout. And my associate and I here, Bill, would like to explain the fishbone is a bit antiquated and it needs to be brought up to speed up to at least the 21st century. So let me introduce myself. My name is Rob, as I said earlier, and not only am I the CEO of a small consulting firm, I'm also the founder of the Blue Dragon Hyper-Integrated Causal Analysis methodology. More on that later. But I'd like to tell you about my background a little bit in four parts. First is the military. I started off in the nuclear Navy. I was a submarine officer, and I was certified on 3 reactors as a supervisor, went forward to be a ship driver, and that was a great experience. I naturally transitioned from the nuclear Navy into commercial nuclear power, where I spent the next 20 years. After 20 years in commercial nuclear, which included a stint in the Nuclear Regulatory Commission as a regulator, I moved on, started my own company in 2006, and since then, I've been a senior policy advisor for the Department of Energy, working at Department of Defense sites and Department of Energy national laboratories and the nuclear weapons complex, solving their most complex problems. Most recently, Bill and I have been developing Blue Dragon Hyper-Integrated Causal Analysis, and also we're training other folks around the country and even around the world on how to apply the most advanced methodology for solving human-centered problems in our modern socio-technical work environments. And now I'd like to introduce my friend and associate, Dr. Bill Toth. Bill?
Thank you, Rob. And incidentally, Rob's in Florida and I'm in East Tennessee. Just so it looks like we're pretty close here on the screen, but we're actually in different places, the miracle of our virtual world. So as a point of introduction, I want to talk about my career in 4 phases. The first phase was right out of college. I went to school here in Tennessee and moved to General Dynamics in Fort Worth, where I worked at the plant making F-16s and doing hard engineering work as a BS in electrical engineering. It was hard technical systems engineering work, and there was very little that I really had to deal with at that point in my career with the human factors. At some point along the way, my wife and I decided to raise our family back here in East Tennessee. After about 5 years doing aerospace, she's an electrical engineer as well. And we moved back to East Tennessee, and the jobs that were available were at the Y-12 Nuclear Security Facility. So I got a job there, and at that point I was dealing with facility security, particularly nuclear security. And I focused a lot on complex systems and really began to see the aspect of the human factor as it pertained to effective systems operations. At that time, I got a master's degree in industrial engineering, where I really studied, that was back in the days of TQM, so I studied a lot of TQM and then also classical management theory. At one point along the way, the entire program moved from the Y-12 facility to the Oak Ridge National Laboratory, and we went global. So the third phase of my career was the global phase, where I took the skills that I had learned along the way and moved out into the world of radiological nuclear nonproliferation. So a lot of trips to Russia, and then after our relationship with Russia crumbled, I began to look at radiological protection, around the world. I finished a PhD at that point in time in organizational systems, where I focused on organizational psychology and general systems theory, an interesting mashup. And my research work was in very bad things: mass killings, espionage, and high consequence industrial accidents. I did that for, I guess I got 30 years. And about a year and a few months ago, I retired from the Oak Ridge National Laboratory and joined Rob, which is the segue into the 4th phase of my career, which is now this great opportunity that we've had to work together, look at this structured methodology called Blue Dragon HCA, and really focus on aspects of education. So that's where I am today as a consultant to the Blue Dragon team, and look forward to the conversations we're going to have today.
Hey, thanks a lot, Bill. And with Bill in our organization, as he said over a year ago, we made some major advancements in the theory and the science behind what is called the ACA framework. And so we're excited to be working together, taking this to a whole nother level and reaching a much broader clientele, as well as other industries besides simply defense and energy. So we're looking forward to speaking to folks outside of those industries. In fact, anyone that's experiencing serious recurring issues that cost a lot of time and resources, this is exactly where we excel. Well, without further ado, why don't we dive into our presentation? In the next 30 minutes, we want to talk about the history of the Fishbone, how it was first introduced, how it's being used to this day. And then we're going to give you some thoughts on how to update it. If you love the Fishbone and you want to, still use that framework, all right, but I'm going to give you some thoughts on, let's make it work a little bit better than it is. And then if you really want to update and actually graduate to a modern, lean, agile, scalable model, we have developed a model called hyper-integrated causal analysis, which is an upgrade to root cause analysis. Very modern framework, integrates so many of the things that Bill's research has brought to light, so much of my 35 years of solving problems at the nuclear weapons complex and nuclear reactor facilities. So as soon as I left the nuclear Navy, I ended up at a commercial nuclear power plant, happened to be on the bottom of the NRC watch list. So we pursued the Deming Prize to help get this utility out of the black hole it was in. And we pursued the Deming Prize out of Japan. So in 1989, my company, Florida Power and Light, won the first Deming Prize in the world outside of Japan. My role was to be a root cause subject matter expert. And that was in 89. By 91, I was an instructor for root cause analysis. So that's how far back my experience goes, leading teams for reactor scrams and other very complex, very dynamic situations where it's not just the equipment, it's the human interactions with the equipment. It's the organizations that were there. It's the infrastructure. It's the culture. All those things made the issues much more complex. And so one of the tools that I was taught of, the 50 tools that I learned during my training for the Deming, was the Fishbone, something that was put on the map at Tokyo University by Dr. Kaoru Ishikawa way back in the 1940s. And so this is a tried and true, really wonderful process, right? He invented it at Kawasaki Steelworks to just show us how causal factors work together. And it was basically brainstorming a set of causal factors based on different prongs of attack. He calls them bones on the fishbone. Okay, fine. So 1940s, right? Sounds like a long time ago, but I did a poll this week in support of this exact webinar. And I asked a poll on LinkedIn, hey, how many folks are still using the Fishbone and the 5 whys as their primary root cause analysis methodologies? Out of 109 professionals that answered the poll, 78% are still using the Fishbone and the 5 whys. So let me step through a couple of slides to give you what I think. What if we had never evolved from the telephone from the 1940s to what we're using today for communications, right? What if we had never upgraded from our television sets to what we're using today, the smart TVs that can just stream everything? And even worse, this is my favorite, what if we had never updated our automobiles to the kind of stuff that we get to play with today? And I myself have a 600 horsepower car, and I couldn't dream of being in some of those old cars. But anyway, when we think about the Fishbone, and to this day, here's what the American Society for Quality is teaching, and what is Lean Six Sigma teaching, and what are academic institutions teaching. They're still teaching the Fishbone in its very traditional format. Where is the evolution of the Fishbone? So we want to share that with you today. But here's what we're seeing still being taught to this day. We have the Fishbone, and basically a great visual brainstorming tool to identify plausible causes. But these things that are on the map right here, these are high-level causes. These are symptoms. You got to go a lot deeper than this to really get at the root causes. And you have to be looking for which of these causes are repeating, i.e. they're the primary source of a number of these cause and effect pathways. So when I started using the Fishbone after a decade of using it in commercial nuclear, I evolved it to include the use of Y staircases. Some call it the 5 Ys. So this is actually the very last Fishbone I ever did. It was in 2007 at the Yucca Mountain High-Level Nuclear Waste Repository. And you notice that with only 10 lines of inquiry here, 10 starting points off the main 4 bones, it gets pretty cluttered, but I was able to colorize the common causes that were falling out of the analysis. So you see here 3 blues and 2 greens and 2 purples and 3 oranges, but nobody can tell me which ones are more important. Nobody can tell me which ones are root causes. This is not an ergonomic chart. I stopped using the Fishbone way back, and I flipped to a whole nother model, and I've evolved that model in the last couple of decades. I mean, for example, if you try to draw a Fishbone for what is a modern day approach to solving problems, you would die, right? But you know what? Here's a procurement program evaluation that I did recently. And guess what? If you see here across the top, here are the bones for the Fishbone. And I call them themes, and I call them also systems and subsystems, because now we have flipped from bones to systems analysis. We're going to talk about that. So that aspect of the Fishbone is still here. And guess what? Here are all of the cause and effect sequences that have branched off of those initial sets of symptoms that we identified. And even better, we have the ability to color code results, and we can see how from multiple lines of inquiry, the green path here, for example, these cause and effect sequences are leading us back to a common factor, which is very important. This common factor is the source of a lot of problems that we designated as a root cause. But on this chart, down across the bottom, you see here clearly these are the root causes at the bottom of our analysis. This next level up, we termed significant contributing factors. It's all displayed here very neatly. So we have really evolved in the way we do this. So let me share with you how Bill and I want to bring the Fishbone into the 21st century. And the first thing we want to say is we're not going to toss it all out, right? There's some great things about the Fishbone that we love. And so the ever expandable themes, the bones, we're going to call them systems and subsystems, but the ever expandable bones and themes on the Fishbone are fantastic. Secondly, the cause and effect relationships that are displayed. We don't want to get rid of that. That is the bread and butter for root cause analysis, but some things are quite outdated. The framework is very difficult to draw. It's hard to tell what's what. The approach is way too simple for the kind of problems that require a root cause analysis. The Fishbone is not a tool, a real tool for root cause analysis. And it's also a very static process, as you see here. So, and Bill, whose research and whose PhD deals in this area, is going to expand a little bit about what is the static process.
It's a good part of the conversation to introduce this concept of static versus dynamic, system statics or system dynamics. And I'll do it with a story. I was at the Y12 facility, and there are 3 facilities here, 3 DOE facilities here in the Oak Ridge Valley, the Oak Ridge National Laboratory, the Y12 Nuclear Weapons Complex, and the East Tennessee Technology Park, formerly the K-25 Gaseous Diffusion Plant. So I was at the Y12 facility and got a call from the K-25 site and said, we have a serious problem with the fire protection system plant-wide. So they borrowed me for a little while to come over there, and borrowed me for a year to come over and look at and work on the fire protection system. When I got there, the Fishbone description of what the fire protection system and the organization around it was supposed to be was already in place, and yet they were still having these problems. So another member of the team, somebody that I really admired a lot, named John Piccolo, was sitting in the middle of a circumstance where I found really illustrative. He asked the simple question. It actually turned out to be a very hard question. What happens first? And it erupted the room. He had got all the stakeholders in the room. We was talking to virtually everybody associated with fire protection, management down to the worker levels, and giant fight erupts to find out just what happens first. And he was sitting there in front of something that looked very much like what Rob had showed. And the bed sheet with sticky notes, and he waited patiently. After an hour and a half to two hours of fighting went on, while people argued about what happened first. When he finally got down to something that seemed reasonable, he wrote that and on a sticky, and he put it on the page. Then he asked a equally provocative question: what happens next? And similar fights happened, similar time. Long story short, this process got better and better over time, and people began to understand the dynamics behind the statics that were represented already by the Fishbone. Once they did that, and they came up with these not only linear timelines, but looping feedback pathways, we found duplication of effort, we found labor relations issues, we found all kinds of things that never would have been evident otherwise. Now, I know one of the comments I hope will be, well, the Fishbone can also accommodate dynamics. Yes, it can. However, in practice, it rarely does, from my experience. I usually come in and the Fishbone turns out to be a static description of organizations and almost a work breakdown structure, if you will, of the things that we can see and observe from a static perspective. It rarely talks about some of these dynamics, and so because these are multiple system dynamics and they clash in important ways. And this is really where we find a lot of the problems. So the Fishbone is good in terms of laying out the statics, but I think it falls short when it comes to the dynamic aspects.
And that's why we think we need to make some changes here. So what we'd like to show you in the bulk of this presentation is from here on out, the next 15 minutes or so, let's talk about how to bring the Fishbone into the 21st century, the ways that we can upgrade it from little to big. All right, so 3 things we're going to cover real quick: how to integrate the Fishbone with, at the very minimum, why staircases, and not have it be simply a brainstormed list of symptoms. Secondly, updating from this Fishbone framework that's been around since the 40s, and to start us thinking in terms of systems and subsystems, so we can do systems analysis versus simply the static bones on a Fishbone that we're so used to doing. So let's talk about the first. And this is really straightforward. You saw my picture there. If we simply take the first set of causes, they're going to be symptoms. They're simply going to be symptoms. And you really got to dive deep in there and start asking why this is happening to get at the deeper seated causes. And so you see here how this chart might look if we marry the Fishbone, traditional Fishbone, with a Y staircase. And by the way, 5 Ys, that's just something Toyota coined in the 70s, but the 5 has nothing to do with it. Most of my stuff goes 10, 20 plus questions deep. So now let's switch this framework to a stacked format. This is the cost tree format, much better than anything you've been using. So the Fishbone is bad news. It's not very ergonomic, really hard to draw. Once you get into this stacked format, it is so much easier, so much better. You can actually just continue to add more bones to the right if you like, and your cause and effect analysis will be stacked very nicely and go as deep as you want without creating these crazy diagonal things that mess people up. Switch to a cost tree format. Number 1, you have a huge leg up on the Fishbone. And number 2, why don't you add some motion? Like Bill said, things are not static. Issues tend to be dynamic. So if you simply bring in a timeline that you can evaluate and help you identify better symptoms, like somebody does something wrong, that's a symptom. That's a human performance cause, but it's a superficial symptomatic cause, and go into cause and effect from there. So when you continue to evaluate and do causal analysis, now it's a lot easier to color code and track your common causes, because the worst causal factors, the root causes and contributing factors, are going to be a common source of problems that are going to manifest themselves in many symptoms. So we identify the symptoms, we work backwards to reverse engineer our way to other causes, and when they start hitting on these common causes, those are the deeper seated causes, and that those are closer to what we're going to call the root causes. But at least you have a nicer chart, very ergonomic. You can go as far to the right and as far down as you need to. And to make that point, let's show you what one of these charts could look like. Very straightforward. This, of course, is an HCA chart, not a simple cost tree. Across the top is the timeline. And right here you have what would be the bones. These are actually the themes and sub-themes that showed up, the systems that we're evaluating. And then here is the first level set of symptoms. They form our initial lines of inquiry. So the first set of symptoms that you would brainstorm like out of a fishbone, they get turned into a question. Why is this happening? Why did that happen? And from there on out, we jump into cause and effect analysis using the subject matter expertise of whoever we can bring into the room to answer the questions. And once again, you can see how we're tracking these common causes from anywhere they show up on the chart so that we understand which ones are the more significant causal factors. Here you see in this row, because this is not a finished chart, this is the row where we started to identify some significant contributing factors because they're common to a lot of problem areas. And in the end, some of these drop down, and we had another row down here of the root causes. So hyper-integrated causal analysis takes in a lot of the things that you're currently doing separately. A lot of us learn, as I did, and for 20 years I've been doing events and causal factors charts, barrier analysis, right? Or the fishbone or a fault tree or comparative timeline analysis, task analysis, change. All those things are happening individually. So let's take what looks like a basic chart, the stacked cost tree approach, and let's bring it into the ACA format. And you see that they're still captured here. We still have the timelines. We have our systems/themes, which are the bones. We have the lines of inquiry, which are the high-level symptoms that we initially identified from looking at the timelines and other things. And we have our cause and effect, and you can see here how we're tracking common causes. So let's sneak in and take a little closer look. We've added another wrinkle, which is identifying the requirements that apply to this particular area. So we call these the line of defenses. So now with the requirements in place, we have what should have happened, how things should be done correctly. What were the requirements to keep us safe? The timelines tell us how things actually happened. So what happened versus what should have happened. Guess what we can do now? Comparative timeline analysis, task analysis, change analysis, and most importantly, barrier analysis, which we call the analysis of defenses. So once we start analyzing these defenses for effectiveness, we start coming up with the high-level symptoms. There was a blade guard removed. The requirement says we have to have blade guards on miter saws. So we asked the line of inquiry, why was that blade guard removed? And these become our starting points for our analysis. These are the lines of inquiry here, which are all that the fishbone typically identifies, this initial set of symptoms. And now we get into the cause and effect with subject matter experts. And to show you again what a extremely sophisticated, complex problem looks like when you get to one of these. This is a year old. This is a $500 million capital asset project that went south for the government. Now, the government was willing to spend 50 people for 6 months to do this. And we did it in 6 weeks with 8 people. So number one, the efficiency gains is unbelievable. But once again, I'd like to show you that we have up here 6 timelines, not one. So we can be very sophisticated with the timelines. We have in this next line all of the requirements that applied. Then we had all of the systems we evaluated right there. And the systems analysis is much more in-depth and involved than a simple basic bone on a fishbone. You see the lines of inquiry that were generated in orange, and then the cause and effect. You see the color coding for common causes. And to highlight even further how important it is that we look at systems and systems that are impacted by whatever problem we're looking at. This is the kind of stuff we looked at for this capital asset project. The regulations, how we manage contracts, how we manage the oversight of the contract, construction, design, etc. These are all of the subsystems that should have made this capital asset project work well, but it fell apart. But now Bill is going to go a little bit deeper into this switching from bones to systems and systems analysis. Bill?
Yeah, just to highlight and maybe to highlight this idea of systems. Oftentimes, and I'll use an example from the security world, oftentimes we have kind of a singular systemic approach when we really need to be more intentional about looking at it from a multi-systemic perspective. In the security world, we have security systems, and we can define them and identify them as needed, but we also have production systems, and almost invariably, production and security are at odds. Security slows down production. And therefore, we need to look at them as two separate systems that have their own dynamics, and that they interact and oftentimes clash. So that's just an example of two systems which should be looked at if we're looking at a security problem, a complex security problem, rather than just one. Obviously, there are many more systems involved. If we talk about security, we can add on the response system. We can add on human resources. We can add on some kind of regional education program, which is the thing that we did in Ukraine. So we will get closer and closer to the root cause and an effective sorting out of these issues the more systems we look at. If you think about it, it becomes almost overwhelming. And that's why a tool like Blue Dragon HCA is important to kind of sort these things out. The image that comes to mind when I think about this all the time is a bowl of spaghetti. It's lots and lots of systemic lines, dynamics, all worked out together. And the only way that we can actually sort of really do a decent analysis is we pull these strands of spaghetti out, look at them individually, because they're going to have strengths and they're going to have weaknesses. They're going to have holes in their own defenses, but they're also going to have problems in their interaction, problems in the relationship between these interacting systems. So I think the only hope that we have to do this is a structured, rigorous methodology that separates the systems first and then looks at the way that they interact. And it's close enough to lunch that looks pretty good to me.
It is lunchtime for us. Not so sure about the UK and Qatar. But let me give you an example where we have an equipment issue and how we would also tackle that in a similar fashion. So we were sent to an Army depot in Kentucky to look at why the compressed air motors that supply the vital air that you need to have to be in bubble suits, to be in a room where they're destroying sarin gas and mustard gas. And these motors are quite large, and they had 3 trains of motors, and they each failed consecutively multiple times. In fact, 7 failures in 11 months, 6 root causes, and none of that could come up with the answer. So we did what you would expect, a fault tree analysis of the mechanical and electrical failure modes. We did troubleshooting. We figured out where the faults all happened, but then we used those as insights to generate lines of inquiry. How did we come about where we didn't grease the bearings for 3.5 years? That was the failure mode. Well, we put it into our lines of inquiry, and here you can see, once again, and I'm trying to get my little highlighter going here, you can see the 3 timelines up top for the 3 trains of motors. You can see the events in the hot pink stickies, the 7 events. Here you can see all of the requirements that apply. The bones are right here, and some sub-bones, and of course we call them systems and subsystems that we evaluated. There they are. The initial set of symptoms and insights, like the bearings were not greased for 3.5 years. We're not just going to fix that. We're going to find out how we got here. And that's what this whole cause and effect analysis is intended to do. And this is halfway through. We didn't really get a photograph at the end of this one. You can clearly see how much we can do and how a lot of complicated things can come to light very quickly. In conclusion, the fishbone, as used, is now officially a fossil. It is time to reinvigorate the fish, to allow these fish to swim in a more fluid, dynamic environment, which is really the complex environments, the socio-technical environments that we're finding ourselves in, like the nuclear weapons complex. And so we need something dramatically more capable than the fishbone. However, most of my clients still have the fishbones and the 5 whys itself, which is no more than a building block, as the approved root cause methodologies. It is time to do something much, much better than that. In summary, we want to reinvigorate the fish. We want to update from the 40s version to more modern standards. And at the very least, you can switch to the cost tree style framework and keep the bones and keep the cause and effect, which is, again, another building block. Bill?
We need to consider motion, and we need to think about systems, multi-systemic approach and system dynamics, because these things are complex and they interact in complex ways. They don't just overlap, they interact in very complex ways. So thank you for your attention, and we look forward to the ensuing conversation.
Well, Bill, I think that about covers it. Thanks everyone for joining us today for this webinar on why organizations are choking on the fishbone. And we hope that we have helped you to liberate yourselves from the fishbone in its present form. Bill, any final thoughts?
Yeah, I'm really happy to be a part of this conversation. I think this work for critical problem solving has such high consequence and is so important that I think it's essential that we continue to keep this conversation alive, look for creative solutions to our most complex problems, because I really believe that we're going to save a lot. We may save money and save lives. So thank you for being a part of it, for being in the conversation, and I look forward to hearing from you soon.
Fantastic. And to that end, first of all, we're going to post this webinar online, probably on YouTube, so folks that didn't have a chance to see it can take a look at it. And also, if you want to stop and pause any part of this, you can also call it up. I noticed some of you are actually taking screenshots. You don't need to do that. We'll give you the whole webinar here as soon as we can possibly publish this. And we'll also include our contact information in case any of you want to learn more or reach out to talk to us about Blue Dragon ACA. It's been our pleasure. We hope everyone has a great rest of the day. And now we're going to stick around and take your questions. By the way, we have a chat, so you can type any thoughts or comments or questions on the chat box, or you're free to unmute and give us a question.
I have one.
Vince, go ahead.
Yep. I didn't fully understand.
Vince, introduce yourself and where you're from. That'd be nice.
Yep. Hi, my name's Vince McSkimmings. I'm from Northern England. I work as an operational excellence engineer in the plastics industry. We use the traditional fishbone diagram regularly for root cause analysis in our manufacturing processes. But on your model, I didn't quite understand how the timeline function works. Do you kind of, if you have a problem and you want to do a root cause analysis, do you kind of open this up as a live document and then keep adding information as new events occur, or do you do it all retrospectively? Or
I'll be happy to answer that. And let me go back to that diagram so everyone can follow along. And I'm going to remove all the pesky little ink on it. So, whoops, sorry. What we do right up front once we have an event, Vince, is we do a fact-finding session. And you see here on the left, there's this little red box called fact-finding. And the fact-finding, the initial critique for an event, is meant to identify the sequence of events. So we get witness statements, and we get whoever was there to give us what they saw happening. So we develop usually more than one timeline. This chart only shows one because it's a teeny tiny little thing. But usually we have 3 or more timelines to cover the work controls timeline. So think about this. What was the timeline for how the work was managed? Then we have the human performance timeline for what humans did before, during, and after the event. And then we usually have, at minimum, a 3rd timeline for what happened after the event, the event response timeline. So I love to have at least 3 events to cover those. And I've had as many as 7 timelines to cover different aspects that, if you look at the next chart, gives us a lot of granularity. I can't focus in on this one, but there are 6 timelines on this one to cover a lot of the things that we needed to cover. And some of the times, the timelines marry up with the systems theme. So I want to evaluate what happened in terms of the management of the Department of Energy order for capital asset projects. So that timeline only covers what the government did to award the contract and all of the different inspections and evaluations. So imagine, instead of a gigantic long timeline, we had a number of timelines. That makes it a lot easier to manage. But now here's how we use it, Vince. The timeline is what happened. The defenses, the requirements tell us what should have happened. And we compare the two. So if you look at this example, defense number 1 says our safety program requires miter saws to have blade guards installed. The timeline says we remove the blade guards in July. So now we have a symptom, and that symptom is turned into a question. Why did we remove the blade guards and not reinstall them? That's how we attack every single one of these. So we do the barrier analysis in comparison to the timeline, and it is a living document. It is a live document. It is a document that my timeline doubles sometimes for when I start, because we take input as we conduct our sessions. In the timeline, it can actually get better and more granular.
So Rob, can I answer the question? Vince, I'd like to answer the question also from the design or the pre-event. What Rob was giving is a great answer for the post-event. Pre-event, I would maybe change the terminology a bit and call it process flow documents or whatever. It was that story that I told you in fire protection. We've got a lot of stuff that's written in procedures, but rarely is it really field verified. So there's a whole lot of value that's gained by actually finding out what's actually going on. And I'm talking about physical movement here mostly, but we can expand this conversation to talk about cultures, and normative effects, and why people do or why they don't do the right thing. Sometimes these normative aspects are really powerful in organizations. So I find it really fascinating to go in ahead of time and look for organizational dysfunction as potential areas of failure. And for organizations that want to look at themselves that way, they can avoid some of these problems. So we don't have post-event analysis because you don't have the event. So I find this stuff really fascinating. Just the simple question of what's going on here, because the procedures are not telling the whole story. There may not even be telling a portion of it.
Oh yeah. Hey, thanks, Bill, for the update. And by the way, I want to share our website because I forgot to mention it. If you want to reach out to us, there's a contact form here. But we have information about what it is, what is hyper-integrated causal analysis, and you feel free to scour through our website and get in touch with us if you want to really evolve from the Fishbone, which again we find it difficult to understand why something has not evolved from the 1940s. It is way past the point of its usefulness, and there are simple ways to upgrade this Fishbone to modern standards. We just showed you a couple ways how. But hey, reach out and we'll give you even more information.
Yeah, thank you.
Good. Thanks, Harry. Appreciate it. And yes, we will. This is a recorded session. We will be put it out on YouTube so that everyone can review this and pause it anywhere you want. And I see Shariar taking screenshots, but you can actually get the whole video and pause it anywhere you want and use it anywhere you want.
Thank you.
Other questions?
Or even challenges. Challenges are good too. Tell us we're wrong and why you think.
Yeah, we love it. I want to bring in John Dennis into the discussion. Lean Six Sigma is one of those areas that is phenomenal, right? I'm a Lean Six Sigma. I'm a Kaizen team leader myself. It was wonderful when it came on the scene in 1986 at Motorola. When you see the huge amount of effort involved in performance improvement, so Lean Six Sigma applied at the nuclear sites have been for performance improvement efforts. And what we run into is when it comes to that step in the Lean Six Sigma program that says, okay, and over here, try to find the root causes because that's what we need to solve. They'll teach the 5 whys and the Fishbone. And again, we're using a 1940s and 30s approach in modern day world, which is not going to give us the right answers to what it is we need to improve on. So we got these wonderful Lean Six Sigma tools and applications, but when it comes to the little piece called root cause, we go antiquated. John, what are your thoughts on this?
Yes, well, I first of all, thank you very much for the presentation. I thought it was wonderful, some great ideas, and you've obviously applied this so well already and had great success, so congratulations.
Thank you.
I was interested in the use of the word symptom, and you took the symptom to the left-hand side of the Fishbone on a number of occasions, I noticed. which I would always advise against, because then you are mixing the symptoms of the problem with the causes of the problem. But obviously, it might be, maybe you could expand on how you use the word symptom compared to a cause. I would always relate the word symptom to the problem rather than to the cause, even if there's different levels of cause.
Very good. And so I'll explain to you our concept and our use of the symptom. And I'm sharing my screen again. Hopefully you can see it. So in the classic way the Fishbone is taught, they put up the bones and they look for what are the causes of poor quality product from the management standpoint. What are the causes of poor quality product from the raw material standpoint? These first things that come up, those are high level causes, and that's what I'm calling symptoms. What I see here, all of these first one-off causes, to me, are nothing but symptomatic of deeper seated problems. So everything on this page, I call a symptom. And we need to actually turn that into, okay, what's under working conditions? Well, what's causing the noise that's giving me poor quality product? What's causing the illumination issues? What's causing the humidity problems that's leading to poor quality product? I'm not just going to fix humidity, I'm going to fix what's causing these humidity issues. So this helps you identify high-level causes, and these high-level causes I'm calling symptoms. And so when I go to my chart over here, go back to this chart, instead of calling them, well, here's how we use my chart. So we're looking for symptoms which are causes, and causes are irregularities. So think like a doctor. A doctor, when he brings you into the office, he's trying to find your vitals. He looks for blood pressure, temperature. And if your temperature's fine, right, that's it. But if you have high temperature, is that it? Is he going to cure your high temperature with a ice bath? No, he has to do analysis to determine what's causing the symptom of high temperature or high blood pressure. And so here's what these initial discoveries are. The requirements say A, the timeline says, I didn't do A, that's a symptom. We didn't follow the requirement. Now I need to understand why. And we explore it from a number of angles, right? The human factors perspective, the human interaction with the physical world, and human involvement in modern socio-technical work environments, which includes culture and a lot of things that Bill taught. So we have to explore this modern day problem from a modern approach, which is a lot more involved than what the Fishbone lets you do. So this is much more than I can cover. HCA is much more involved than I can cover here. In fact, it's a 4-day course. So
yeah.
But that's how we treat symptoms. Symptoms are nothing more than the first level causal factor, and we want to go a lot deeper. And we do that through cause and effect analysis, and we have a nice structured methodology to really get some great answers.
Right. I just think that the word symptom needs to be well defined in case people are using it in a different way. So in Six Sigma, often we reserve the word symptom only to the way that the problem is experienced. It's how we experience the problem. So yeah, it has to be explained up front with particularly the way we've taught Six Sigma. So it's
no worries. I completely understand. There's perhaps some translation issues between the two worlds, and we cover definitions up front so we get on the same page and we understand going forward. But we wanted to give you a taste of why the Fishbone is updated. I hope we accomplished that today.
Oh yeah.
We believe the Fishbone has passed its prime, but the beauty of the Fishbone will never die. The ever expandable bones, which we now call systems and subsystems, and cause and effect visually displayed for us to see clearly how we arrived at the root causes is perfect. And that's a marriage of the 5Y/Y staircases with everything else we're doing. And then we've managed to integrate everything into one chart, so we no longer have multiple efforts, disjointed multiple efforts that take a long time. We don't do one-on-one interviews. So there's lots of things, lots of paradigm shifts that took place when we created HCA. And it's been, to say the least, unbelievably powerful, effective, efficient. As I said, we're doing things in 1/10 the time that would take many, many more people, many months to do. I want to give you the stats on that procurement program. the national laboratory was going to spend about 20, 30 people, about 6 months to do the procurement review. We did it in 2 weeks with 4 people. And I'm going to put that, picture back up. So if you look at this picture, we did 124 lines of inquiry. We looked at all kinds of requirements. Procurement is a massive program. We looked at all that. We had 18 involved organizations. We did 14 causal analysis sessions. We dissected the process map of the procurement program. We looked at the corrective action databases and extracted insights. We generated all these lines of inquiry. Everything I just told you took 2 weeks. We came up with 5 root causes, 8 significant factors, and 22 other problems to be fixed, 35 in all. So the efficiency cannot be underestimated with this modern approach. This is a very modern, advanced approach. The Fishbone can't even begin to hold a candle to this. Oh, any other? Well, thank you, John. I appreciate that engagement because, yeah, it's pretty cool. And you can tell Bill and I are very excited to do this. And not only are we doing it, we go out. I've been going out about 3 times a year to do these major investigations for Department of Defense or Department of Energy in the United States. But also we teach it now. So we have our own learning management system that so we can give our courses online on demand. And there's multiple level courses, one for management, one for beginners, one for advanced. So we can meet anybody who's trying to be certified as a root cause analyst can take our BD2 course and get trained up on everything I just told you about ACA. So very popular. It's already been adopted by the National Weapons Complex and the national laboratories in the United States. So we've got good traction here. And we hope to get around the rest of the world eventually.
Ron, can I ask a question?
Of course.
The cost of the training, is it included in your website?
Yes, there's a published price list right on the website for all of our training. And if you want me to go to the UK and do it in person, that's one price. If you want to take it on demand from anywhere in the world, that's a lower price, obviously. So there's different price points for different styles of training, right? And they're all outlined on the website. Absolutely. The base course is $2,300. So the 30-hour course is $2,300. And if you want me to go teach it in person, it's more than that per person.
Right. How often do you offer the course? Are there set times or it can be scheduled?
Oh, this is what's nice. It's on demand. So every month starts a new cohort. So in July, we just started a cohort with 20 people in it. And on July 28th, they have to have finished the first 12 lessons. And then they meet with me in person to do a virtual whiteboard session. And we're going to solve a problem in person. And then they take 2 more weeks and finish the rest of the course, 20 lessons in all. And then they go to another 2 sessions with me, 5 hours each, one on a Tuesday, one on a Thursday. And I just finished that this week. And we do a medium-sized investigation and a large-scale investigation. We just finished that yesterday. And that's the complete course. So it's about a 6-week process. It's about 18 hours of self-paced training and about 12 hours of with me in person. So it's not all self-paced on your own. You get some instructor-led stuff, but all virtual. So it makes it a lot easier for me, for you. And those 3 dates, the live sessions 1, 2, and 3 are predetermined for every cohort every month.
Thank you.
Oh, you bet. Masood, thanks for sticking around. Appreciate it. Reach out if you need any more information. We're posting the website on the chat room here. My CIO reminded me to make sure that's on there. That's a great starting point to reach out to us if you need to. So you can copy or just click on that link on the chat there. Anyone else have any questions? We will talk all day. We love this. This is what we do for a living. So and if you want us to help you solve a problem, reach out. We will do what it takes, either virtually or in person. And we'll help you set up an investigation for your most complex issues. And believe me, there's some nasty recurring issues out there in all industries, as you know. In the United States, I'll give you this stat. Just in healthcare, the types of issues that are recurring that are human-centric are costing us almost $1 trillion a year. This is from the American Journal of Medical Association. The cost of IT, poor software quality in IT, from CISQ, who publishes this report every year, is running, on average, over $2 trillion a year in the United States per year. Those two alone are $3 trillion a year in waste because we can't solve recurring problems in the United States in those two areas. So the cost of this is enormous because we don't know how to solve problems. In many cases, all these industries like aerospace, pharmaceuticals, food and drug, they're using antiquated methods and they're just not getting it.
May I ask, are you familiar with Douglas Hubbard and the failure of risk management? And how does your work fold into his belief that FMEA is a tool that is not useful anymore?
Wow, that's a great lead-in. In fact, I know Bill has had extensive discussions on the use of FMEA at Sandia National Laboratory, which is one of the world leaders. And Bill, unmute, and you want to field this one?
So what came to mind, I have a regular ongoing conversation with Ian Mitroff at University of California at Berkeley, and he advocates for crisis portfolios, which is really interesting and influential on my work. It's essentially a postulated circumstance that would cause a crisis in a particular industry, and then walking through all of the defenses and walking through all of the responses so that one can continue to have a robust response to that. One of the, and this may be slightly divergent, but one thing we talk about a lot is a failure of imagination. So when something really bad goes wrong, the last thing you want to hear is, I never saw that coming. But that's virtually what everyone says, you know. And so failure of imagination is on the designers and it's on the system operators in the beginning. You know, we need to have better imagination about what can go wrong. Now that can make one a really dark and depressing kind of person if we're constantly thinking about worst case scenarios and terrible events before they happen. But we need those kind of personalities on teams because it's failure of imagination that's keeping us from invoking these kind of tools at the appropriate time. So I'm not sure if that answered the question. When you said what you did, I thought about my relationship with Ian, and he's amazing. He's got a lot of work on this crisis management thing. So
thanks, Bill. And let me add to that, this is a great point, by the way. So in terms of risk management, FMEA has been a stalwart and used, but FMEA can also be static. And so we're trying to convince Sandia and others who are champions in the area of FMEA worldwide that they need to also incorporate some of the dynamics that we incorporate. And in terms of risk management, again, it's not being done very well because too often people are on the right side of this bow tie model, which is post-event. Now we're in the reactive aspect of it, as opposed to doing a comprehensive evaluation of our existing defenses, which is what HCA can do, eliminate the timeline, and we can analyze the defenses and make sure that we're ready for any potential issues. And so we absolutely talk about risk management. We don't think it's being done really well. We agree that FMEA is a good tool, but it needs to be enhanced. Hope that answers your question. We're trying to convince Sandia of that right now.
So Rob, just to add on, you know, the other thing about FMEA, and this is a harsh criticism, I don't think everybody does this, but there's always in the government world an invitation to go ahead and check all the boxes. I completed my FMEA and I turned it in. So when I brought up Ian Mitroff's work, I was thinking about those kinds of failure modes in the crisis portfolio development sense that extend beyond and are more creative in their construction than simply filling out a box to say that I finished this. I mean, I know all of these many quality organizations, and they're under lots of pressure. I mean, it's not necessarily completely their fault. They're trying to move through and meet the requirement and fill out, you know, what they need to fill out. And I think these things have a tendency, in my opinion, to really kind of squelch imagination. So.
But John, can you say
Doesn't mean that they're not useful. It doesn't mean that they're completely useless. They have their, anything that organizes thoughts is a good thing. But what does it do to you in that organization, in that conversation? That's my problem. Sorry,
John, I love learning from others. So would you mind repeating the name Douglas? And I didn't catch
Douglas Hubbard.
Okay. Hubbard, and I'll look him up, and I look up his work. Bill loves to research other authors and get us some intel. You know, perhaps we can use some of his work, or we can confirm that we are in agreement with his thoughts there, which I think we are.
I think you would be, yes.
Fantastic. Very, very appreciative of you bringing that up. That's actually one of those things that we're hard charging, because for some reason Sandia has the world market cornered on FMEA and how to look at safeguards and security type issues around the world. We're talking nuclear non-proliferation and things like that are vital to national security, and we think their methods are antiquated, but we have yet to reach them and convince them of that.
Hey, John, just to follow up, I did a quick look-see, and I do remember the title about how to measure anything. And you might be interested, Rob and I have actually written a paper that I'm presenting in a couple of weeks at the Institute for Nuclear Materials Management. And this hubris of saying that because it's quantitative and I have incredible computing power, I can solve virtually any problem. And so I think what he's trying to say in that book, if I can interpret from the title and where this came into my conversation before, is that there are other intangible things out there. There are stories, there are cultural aspects, there are dimensions which are incredibly influential on the effective operation of anything, but we tend to miss it or tend to give it short shrift because we're after the thing that we can crunch with a computer. So I think the hubris of quantitative processing is something that's going to really hurt us in the long run. So we need, and this comes from somebody who started as a hard engineer in electrical engineering. I think storytelling, I think understanding cultures, I think these things have such a rich input into the way we do analyses that we ignore them at our own peril.
Yes, absolutely.
We're so happy the UK is here and Qatar. Mr. Masood, how does this resonate with the folks in Qatar who I'm guessing also use the Fishbone? Maybe he's logged off, but not logged off. Well, any other questions for us today? Well, the UK has been very well represented here. And also we have Canada and Qatar. I appreciate it. So you guys were most engaging. I appreciate it very much. And we look forward to, we're going to post this on YouTube. We look forward to hearing from you. If you want to have a continuing dialogue, we certainly would love to help. Have a great one, everyone.
Thank you.
Have a great weekend. Take care.
Goodbye.
Bye-bye.
Thank you very much.
Take care.
Thank you.
I know.